Let's take a look at some of the common misunderstandings in the first part of calculus. And the first one has to do with limits, and really the nature of limits. So the limit is completely separate from the value of the function. So the limit is the y value that a function is approaching as you get close to a certain x value. So for example, right here, if I have this function and I want to know what is the limit as x approaches 2, I look at where x approaches 2 and I see that the y value, if it existed, would be 2. But the limit, it doesn't matter if it exists or not. It's just what would it be if it were there. And what it would be is 2. And this is true even if the function is defined somewhere else. The limit is still equal to 2. It's the value that the function is approaching. And so you want to think about, as you're traveling along the function and you're getting closer to this x value equal to 2, what y value are you approaching? You're certainly not approaching this right here as you're traveling along the line. You're certainly not approaching the value there. So if I have a function like this, and I want to look at the limit as x approaches 2 of f of x, assuming that is f of x, that does not exist. And it does not exist because the right and left hand limits are not the same. The function exists, but if I'm just looking at the limit, that's completely irrelevant. If I look at the limit as x approaches 2 from the left, that means I start to the left of 2 and I just travel along that curve, and I want to see what would it be if it existed at 2. It happens to be there at 2, but that doesn't really matter. It's just what would it be if it got there. And so the limit as x approaches 2 from the left of f of x has the y value 2. The limit as x approaches 2 from the right of f of x, while I travel along the curve from the right hand side, and I see if the function existed at 2, what would it be? Well, if it was up there, it would be 3. So this can be confused with continuity and also with differentiability. So the limit can exist even if the function is not continuous. Continuous. And also the value of the function if it exists at all, I want to say the value of the function, if it exists at all, is not related to the value of the limit. Okay, so let's look at a few more examples. Does the limit as x approaches 3 exist? it does not exist because it is not the same from the left and from the right. Does f of 3 exist? F of 3 does exist, and f of 3 has the value of 1. So when do we use all these things together? And that's for continuity. In order to be continuous, the function has to exist, and the limit has to exist, and the value of the function has to equal the value of the limit. So it's three things, but you can combine them into one. So the first thing is the limit as x approaches a of f of x has to exist. The second thing that has to be true is that the function itself has to exist. And then the last thing is not only does the limit have to exist and the function has to exist, they have to equal each other in order for it to be continuous. And now what does it mean for the limit to exist? That means the limit as x approaches a from the right has to equal the limit as x approaches a from the left. So assuming that the limit does exist and that the function exists, then in order for them to be continuous, they have to be equal. And so the limit as x approaches a of f of x equals f of a. So let's see how that works. Okay, so in this example right here, what is the limit as x approaches 2 of f of x? And the answer is 1. It doesn't matter that the function doesn't exist there. What if I added a point right there? That does not change this at all. That's still there. So I think some people get confused on the limit existing and being continuous. A limit can exist and the function not be continuous, but if it is continuous, the limit has to exist. So we have a function and we have a point where we want to know if it's continuous. There are different ways to look at it. One way you can say is the kind of the combined version. So you can say that it's continuous at a. Here's a. If the limit as x approaches a of f of x equals f of a. So as long as the limit exists, and that is what the function actually equals at that point, then it is continuous. That's the mathy way to do it. The observant way to do it is just, can you trace along it with your pen or pencil without having to pick it up off the paper? And if you can, it's continuous. So a function like this, that's continuous. Even though it has a point on it, it's not differentiable, but it is continuous. I said this was the shorthand way of saying the function is continuous, because this is really saying three things in one. It's saying, one, the limit as x approaches a of f of x exists. And it's saying, two, f of a exists. It doesn't equal exists, but it exists. It exits. It exists. Or something like that. And the last one is that those two things equal each other. So in this function right here, the limit exists and the function exists, but they don't equal each other. And I can take it one further step. I can say that in order for the limit to exist, the limit as x approaches a from the left of f of x has to equal the limit as x approaches a from the left of f of x. Which, if the limit exists, then this is implied, but that's number one. And number two was I don't know what I was thinking. Okay, so yeah, so number two is that f of a exists. And so the limit as x approaches a from the left has to equal the limit as x approaches a from the right, which has to equal the limit as x approaches a of f of x. And then 3, in order to be continuous, that limit has to equal the value of the function. Alright, so let's look at some questions here. Thank you to whichever teacher at sausd.us. Let's see. This was this one was Santa Ana Unified School District. So thank you to Santa Ana Unified School District. Okay, so first few are pretty straightforward. I don't think you had any problems with these. So as the x value gets closer and closer to 3, f of x gets closer and closer to 5 times 9 is 45. So that is not a problem. I have this where I can write, so you'll just have to hear me talk. Alright, so the second one you did fine with each of those, so you did fine when you had to factor and find it. But let's take a look at number 4. Use the graph to answer the following questions. So the limit as x approaches 4 from the left, so from the left will be 2. The limit as x approaches 4 from the right will also be 2. So because the right and left hand limits are equal, that is what the value of the function is. It does not matter that there's a hole there. It's not what the value of the function is, that's what the value of the limit is. It does not matter that the function does not have a value there. The value of the limit is 2. What is f of 4? F of 4 does not exist. It's not defined anywhere at 4. And these two things are certainly compatible. You can have a limit and have it not exist. That just means it's not continuous there. The limit as x approaches 1 from the left looks like it's about 3.5 maybe. And as x approaches 1 from the right, appears to be 1. What is the limit as x approaches 1? It does not exist, because the limit as x approaches 1 from the left and the limit as x approaches 1 from the right are not the same. When the right and left hand limits are not the same, it does not exist. Even if f of 1 exists, which it does here, it is 2. Okay, so pause the video and answer number 5, and then come back and see if you got them right. Okay, so let's just check and see if you got these. Limit as x approaches 4 from the left is 7, because as we come from the left, it goes all the way up to 7. From the right, it is 2. The limit as x approaches 4 does not exist, because the right and left hand limits aren't the same, even though the value of the function at 4 does exist and is 3. At 2, we're going to have that the limit does exist because the right and left hand limits are the same. So, although I didn't write them that way, did I? So the limit as x approaches 2 from the left is 3, and the limit as x approaches 2 from the right is also 3. So from the right, traveling down there, down this line, you get to 2, and it is 3. And the limit as x approaches 2 is 3, because it's the same as the right hand limit equals the left. If the right hand limit equals the left hand limit, then that's what the limit equals. And f of 2 itself is defined to be, statement here is either true or false. If f of 1 equals 5, then the limit as x approaches 1 of f of x exists. Not necessarily so. Whether the function exists or not has no relationship to whether the limit exists. B, if f of 1 equals 5 and the limit as x approaches 1 of f of x exists, then the limit as x approaches 1 of f of x equals 5. Not necessarily. That would be true if it was continuous, but it doesn't say it's continuous. If the limit as x approaches 1 of f of x equals 5, then f of 1 equals 5. Again, not necessarily. Those are all false. And I think I'm going to stop here. There was the one question also that was, you were a little confused by it. It had the limit, it said the limit of as x approaches 0 of f of x equals 6, and which of the following had to be true, and one of them was the limit as x approaches 0 of f of x squared equals 36, and that would be true because right here the rules of limits tell us that as if the limit as x approaches c of g of x is -2, then this would equal -2 times -2, which would equal 4, because when you multiply together, so the limit of f of x times g of x equals the limit of f of x times the limit of g of x.